Okay, so the topic for today is rotational kinetic energy. The first question is, what is the kinetic energy? Kinetic energy is the energy possessed by a moving body, or in other words, is the energy of motion. An object that has motion, whether it's vertical or horizontal, has kinetic energy. Kinetic energy is a scalar quantity, which means that it only has a magnitude without a specific direction. These are several forms of kinetic energy. Rotational energy is the energy due to rotational motion. Vibrational energy is the energy due to vibrational motion. And translational or linear energy is the energy due to motion from one location to another. So let's talk more in depth about rotational energy. Rotational energy or angular kinetic energy is the kinetic energy due to the motion of an object and is part of its total kinetic energy. The unit is in joule. 1 joule is equal to newtons times meter. 1 joule is equal to 1 kilogram times meter squared over second squared. The total kinetic energy is equal to the sum of linear kinetic energy and rotational energy. So, linear and rotational kinetic energy have the same form. So these are the equations for them. Rotational energy has the equation of 1/2 times inertia times angular velocity squared. I is the symbol of the moment of inertia. The unit is kilogram times meter squared. And omega, which is the symbol for angular velocity. Omega is equal to V over R. V is velocity and R is radius. The unit for omega or angular velocity is radian per second. And this is the equation for linear kinetic energy. Is equal to 1/2 times m times v squared. M is the mass in kilogram and v is velocity in meter per second. So these two equations are parallel to each other. 1/2 I is rotational inertia and mass is linear inertia. Angular velocity square and linear velocity square. So let's take a look at the charts that comparing the translational and rotational equations.
Equations to rotational, we find an analog for all of them. Displacement S equals R theta, or we could find angular displacement. That's going to be linear displacement divided by the radius. Or velocity equals R omega, omega equals V over R. Acceleration equals R alpha, angular acceleration, or angular acceleration equals linear acceleration over R. Time is the same in both worlds. torque, Newton's second law, net force equals mass times acceleration. Net torque equals moment of inertia times angular acceleration. Linear momentum, P equals mv. Angular momentum, L equals I omega. And finally, kinetic energy, translational kinetic energy, 1/2 mv squared, rotational kinetic energy, 1/2 I omega squared. You have analogs to all of these different values in the rotational and translational arenas. So let's see.
Okay, so let's take a look at a practice problem. Gina rolls a bowling ball of mass 7 kilograms and radius 10.9 centimeter down a lane with a velocity of 6 meters per second. Find the rotational kinetic energy of the bowling ball, assuming it does not slip. What is its total kinetic energy? So we have two questions here. The first one is to find the rotational kinetic energy, and the second one is to find the total kinetic energy. So we know that the equation for the rotational kinetic energy is equal to 1/2 times inertia times angular velocity squared. And this is the moment of inertia for the solid sphere. We consider that the bowling ball is a solid sphere, and it has the moment of inertia is equal to 2/5 times mass times radius squared. And we have the mass here is 7 kilogram, and the radius in meter, which is 0.109 meter squared. We calculate and we got this 0.0333 kilogram times meter squared. Okay, so we got the inertia. So now we need to find the angular velocity. We know that the angular velocity is equal to v over r. The v is velocity. In this problem, the velocity is 6 meters per second, and the radius is 0.109 meter. And we calculate this and we got 55.05 radian per second. So now we can plug in these two to get the kinetic energy, and we got this 50.46 joule. Okay, so the second question is the total kinetic energy. In order to find the total kinetic energy, we need to find the linear kinetic energy. So the equation for the linear kinetic energy is 1/2 times mass times velocity squared. So we have the mass and the velocity. The mass is 7 kilogram and the velocity of 6 meters per second. We plug in the numbers and we got 126 joules. So now we can find the total kinetic energy, which is the sum of rotational and linear kinetic energy. We plug in the number 50.46 of kinetic energy and 126, and this is the total kinetic energy. Okay, so we're done with this. So thank you for watching.